My name is Molly Johnson, and this is my video for Lab 3, the Magnet Lab. By the way, the software that I'm using to record this doesn't let me record and do full screen at the same time, so that's why I'm not in full screen. Purpose. So the purpose of this lab was to calculate the magnetic field of a magnet using smartphone technology. We were to compare our observed results to computed results as done on GlowScript. And to calculate the magnetic field, we applied the Biot-Savart law as seen in the bottom right-hand corner. Setup. So to set up this lab, first I had to align my phone to the Earth's magnetic field. This was because we were only trying to calculate the magnetic field of the magnet, and because the magnet is on Earth, I had to subtract the Earth's magnetic field from the magnetic field of the magnet results to get the best answers. Secondly, I had to calibrate the magnetic sensor on the phone to get the best X and Y values. And then to take the measurements, I put a magnet at the end of a meter stick and measured the distance at specific magnetic field intervals. As you can see, these are all my data collection results. I did this for specific intervals at 20 microteslas, 70 microteslas, etc., etc. And then the averages are all computed at the bottom. So taking this information, I could plot the natural log of the magnetic field in the x direction versus the natural log of r, which r was the distance from the magnet to the magnet sensor. As you can see on the graph here, it comes out with a y equals mxb equation, which in this case translates to the natural log of the magnetic field in the x direction equals the natural log of k, a constant, plus n, the slope, the experimental value, times the natural log of r. We can use this intercept, the natural log of k, in order to calculate regular k, and using regular k to calculate mu. Mu is the magnetic moment, which we calculated to be 1.54. Using the magnetic moment, I put this in GlowScript to create a function that will find the magnetic field at a specific observation location. This essentially is just putting the Biot-Savart law into use. Further on to the coding, I created multiple arrows to represent different observation location vectors for the magnetic field. As you can see, the R's represent the locations, and then the B represents the magnetic field at said location. The resulting product looks like this. The magnet is represented by the small white cylinder in the center, and then the arrows represent the magnetic field vectors. And as you can see, all of the values for the magnetic field are shown below. For the second half of the lab, we also had to compute the magnetic field of an off-axis field. In doing so, I got the average distance, the average perpendicular distance to be 0.233 meters. The average measured value for the magnetic field in the x direction was 1.67 times 10 to the negative 7 teslas, and the average measured value for B in the y direction was 2.8 times 10 to the negative 6 teslas. The corrected By was 5.54 times 10 to the negative 5 teslas, and this is corrected because it is actually the average measured value minus the value of the Earth's magnetic field, as talked about earlier. And then B net was equal to 7.61 times 10 to the negative 5 teslas. As you can see in the coding, I also computed the magnetic field at a 45-degree angle, distance d, which is the same thing as the off-axis field, using the function that I wrote on GlowScript, and that is represented by the magenta arrow pointing in this direction. And this is the vector for it, and the magnitude was also computed just for fun. So in comparing these values differ, and that is because, well, A, the experimental value is in real life, and B, the GlowScript value is all theoretical. The difference in these results could be explained by inaccuracies with my phone. My sensor might not have been completely accurate, unaccounted for magnetic fields. I did this experiment outside to try to minimize the effect of unaccounted magnetic fields, but of course they're ever present. And human error in data collection. This lab was very difficult to do, and it took a lot of time and a lot of eyeballing, trying to figure out how to set it up right, etc. Observations and questions. So in doing this lab, the magnetometer far away from the magnet had a 0 magnetic field in the x direction. This was the calibration of the Earth's magnetic field I talked about earlier. And as the magnetometer moved closer to the magnet, the x component increased. So if I hadn't orientated my experiment to compensate for magnetic north, then I would have accidentally included the Earth's magnetic field in my calculations. It would have been much harder to try to separate the difference between the magnetic field of the Earth and the magnetic field of the magnet. And if I were to stick two magnets together, the results would be similar, but it would be multiplied by 2 because it would be twice the amount of magnetic force. So in conclusion, we calculated a magnetic field using smartphones. We recorded data observations to plot the natural log of B of x versus natural log of r, and that led us to find the magnetic moment. Using the magnetic moment, we were able to use GlowScript to make a model of the magnetic field and compared our experimental to computational answers.